Why it is important? Because multi-temporal imagery is required for infrequent observation opportunities. For example, if you want to monitor flood scenarios, obviously you would like to monitor on a daily basis. Okay, so you need high temporal resolution data. Then short-lived phenomenon. For example, if there's this flash flood comes in, okay, just comes 1 day or 2 days goes in, but your satellite has already passed yesterday, and you are waiting for the next 10 days later, the satellite is going to pass. So nothing information in between. Okay, blank. Then rapid response. There is a bushfire happens, or fire happens. Okay, okay. Nowadays we have these drones, or we can also send it our aircrafts as well to collect the data, and so on. I think stop. You have to have lunch. We quickly finish after this. Otherwise, if you don't understand all those tools that is available, it becomes very hard. Okay? Good. Any questions you have before we end?
Sir.
Yes.
Sir, what is the utility of 80 meter or higher resolution, lower resolution?
Which resolution? Spatial resolution. Think of it, very easy. Like you are talking low resolution. It's not utility. So because we wish to have very high spectral resolution, high radiametric resolution, high temporal resolution, and high spatial resolution. But based on the physics that we have, it's very, very difficult to achieve everything. You've got to compromise one or two. So if you are having very high resolution, high spatial resolution, obviously you have to compromise some of them. Okay. Now, low spatial resolution automatically when you are going for, let's say, hyperspectral. So the low spatial resolution comes in already about maybe 5 meter. You can't achieve about 0.10 meter or something like that. But they're designed for different purposes. Okay, and they are designed actually for better coverage. You know, like I was giving you the example yesterday. We have one satellite which was launched in 2019. It's called by Japan. It's called Villuri. Okay, that satellite takes the data in every 10 minutes. But the spatial resolution is 1 kilometer. But that is designed actually for specific purpose. That is designed to monitor the vegetation, the water globally. Take 10 minutes. Right? What do you want to do actually with every 10 minutes with the 0.1 meter data? Right? See, getting data is good, but then also ability to process the data and getting that, you know, also that is another. Okay, got your answer?
Sir, one question. The spatial resolution is different for different sensors.
Yeah.
When I get a spatial resolution, when I get image from like 80 meters or 30 meters resolution, in this pixel, in the one settlement area, one tree or one barren land, or one local open field is come, then the satellite image, when I supervise this image, which category is it may be shown?
Which category means?
Like which land use land cover it may be shown, like barren land or settlement or.
So that is the thing, because imagine now, just now I was giving you the example, right? That box diagram.
Yeah,
okay.
it's a 1 pixel.
So let's say 1 pixel.
Yeah.
So then it's supposed to be that particular category. If it is barren land, it's a barren land.
In 1 pixel there is a barren land and there is a road also.
So that is what you call mixed pixel values. So to separate between these mixed pixel value, it's a science by itself. Okay. I mean, you can't do anything about it.
But sometimes it's a misinterpret or
because it's a mixed pixel, you can't do anything.
The field visit or verification would be
Or another way is that, let's say in the next, maybe if you have, let's say temporal resolution is high, okay, and the weather condition has not changed much, right? So if you are taking another, then you have to rely actually on the pixel value of the surrounding pixels. Then you take the mean aggregate.
even if I take the same image in another monsoon,
It will be different. Yeah, because the weather condition will change, the light condition will change, the sun positioning will change. It's as good as like when you take a photograph. You take the photograph, but throughout the day, the quality of the photograph is going to be different, right? Because all depends on the moisture, all depends on the humidity, all depends on the sun, irradiance level and all those things.
Sir, and one more question, which day is better for mapping in coastal region which has the MSM in minus, like East Mednapur or including Sundarban region?
High. Always falls off. No, because you are just focusing on, if it is big area, because again you have to look at the size of your area, because this cost can be very, very expensive. Satellite data are not cheap.
Very much expensive.
Okay, one scene, as I told you, can run into excessive of few $100s. It's about 25 square kilometer. That means 5 by 5 square kilometer. So that's why you've got to be very particular about the cost of the project. You want to do best assessment, but then you are running into millions of rupees, then what's the point? Right? So that's why actually you've got to come up with the best solution, what kind of input data that you need, which is sufficient enough to give you the kind of information that you need. Okay, we will learn that about the input data when I talk about the input data for various applications, especially for geohazards. And there are so many, at least about 4 or 5 assignments I have kept. So I'll keep you busy as well. Okay? All right, any other questions? No, you can ask later on. Okay. I can put this in here. For the platform, we have learned about 2 types of platform, right? One is aircraft, another one is satellite platform, right? Then the third one is the UAVs. That means actually these are the drones, what we speak. Okay? So drones, we have different types of drones, right? There is hectocopter, there is rotary wings, and there is like small plane kind of thing, that means the way they can land and can take off. Okay? So depending on that, they have classified the drones as well. So the most important aspect here is that what kind of sensor that we can install. Okay? You can still install the RGB cameras, okay? And you can also install the LiDAR. So LiDAR is light detection and ranging, which is they use the laser pulse, mostly in the ultra, what you call the, it's working now? No, okay. Yeah, so it emits the laser pulse like this one, but obviously they have a range of laser pulse. This is not what actually they use it. They have different wavelengths, okay? So once actually it is mounted here, below here, so the laser pulse is being transmitted from this sensor. Then they also have a receiver as well. So the sender actually sends the signal. It goes and hits, actually interacts with the target. Then part of it bounces back. So that is what actually they captures here, and they accordingly they measure the distance. So that is what they collect the 3D point clouds of the terrain. Okay, it's very, very useful tool, especially to collect the 3-dimensional information about the object. Okay, or about the terrain. Also, you can have multispectral cameras. That
is there any difference between laser scanner and LiDAR scanner?
No, same. It's the lasers. Lasers, they call the laser systems. The LiDAR actually is the scanner. I mean, it's just a terminology like machine learning, artificial intelligence, or data mining. Okay. So,
how can we in LiDAR there are different types of layers. मतलब कि एक पहले एक
that I will come. That will come later. Okay. Multispectral cameras, then you have actually, that is camera beyond the visible spectrum. That means you have red, near infrared, mid infrared, short wave infrared, then far infrared also, right? So that is beyond. And also you can have thermal cameras as well. Okay, so depending on what is the need, actually you can use for. Mostly, when you use the infrared and near infrared, they are very, very useful for vegetation mapping. The reason being, because they are sensitive, the way actually it interacts with the vegetation. And there is a very famous indices that is being used to monitor actually the health of the vegetation. That is what we call NDVI, Normalized Difference Vegetation Index. There are multiple number of actually indices. In the water also they have different types of indices also. Okay. So NDVI works always NIR minus IR, that means near infrared minus infrared, divided by NIR plus IR. Okay. So basically, because these are images, these are pixels, so it's very easy to calculate that. You can differentiate and you can be able to calculate the NDVI values. Okay. Now, as I was mentioning, there are different types of UAVs. You can see here there are some rotary wings, there are fixed cameras, fixed wings. This is fixed wings. Fixed wing means this like a little aeroplane. Okay, it will take off, horizontally will go and take off, and then also land like horizontally. Okay, whereas you have the hectocopter, so they are like helicopter. That means they can take the vertical takeoff. Okay, but some of them also can be a bit of mix as well. Okay, so there are different types of UAV used, but regardless, doesn't matter. It's at the end of the day how we collect the data. Okay, so there are something called hybrid type of UAVs as well. That means tilt rotor and also tilt wing. Okay, we are not going into very detail about this. Then the same thing again, you call this also unmanned aerial vehicle as well, right? Because anyway, they are not manned, isn't it? They are unmanned, so it is called UAV. They are called UMS, unmanned systems. So it's different kind of nomenclature they use. Depends who is being used, who is being using them. All right. So then we go to single image frames. They have also, they can at the same time, it also take the aerial videos. Okay, like the bloggers, they use the videos. They don't use like they're not using for remote sensing applications, right? It's hot. Huh? Very hot. Why you not use it? You off the AC? 50 people will die. Then aerial videos, then LiDAR, obviously also you can install the LiDAR, and it is getting cheaper day by day. Okay, compared to 10 years ago. Now actually the LiDAR based systems are, like some of my colleagues also, they are developing new generation, cheap quality LiDAR based cameras and UAV systems. Okay. What are the applications? UAV applications in surveying and mapping? Plenty. Like what actually you can see in remote other space one remote sensing applications, but obviously it's got daira coming. Okay, because the areas that it captures the data, obviously it's very less. But certain areas like certain applications like flash plot monitoring, it is very useful. Okay. Then you have obviously you have for topography, cadastral mapping, DM generation, infrastructure planning and design. Like these days, when they build the construction sector, they also monitor every day using the UAV. Okay, so very less number of people nowadays being used to monitor the construction site as well. Then you have for disaster management, emergency response, as I mentioned, for flash flood, natural resources, and so many archaeological site conservation as well. Okay, traffic management as well, and so on. LiDAR. You know how the LiDAR system works. I already mentioned. So it always LiDAR is beyond this, okay, beyond the red band, okay. So basically it is near infrared, okay. This is how actually the system looks like. All right, they have the antenna here, GPS antenna here. So then there is a digital camera here. At the same time, when it is collecting the point clouds, at the same time also it is capturing very high resolution photographs. Okay, that is what you call as orthophotos. Okay, or you can, yeah, usually we call it as orthophotos. Someone else telling me? Okay, and then obviously you can plan your mission, but this is a aeroplane based LiDAR system. These are very expensive. Simply because you got to plan, you got to get the approval of flying, then the fuel, then you have to pay actually for the renting the aircraft as well. So it can run into millions of dollars. Okay, but these missions are very useful for bigger area. Okay, I'll show you some examples also the data that we have captured. Then what else? So it has a very high quality inertial and GPS global positioning system, which gives you a very precise location of the data points. So how do we capture the LiDAR data? And I'll give you some actually mind-boggling number. The next slide, I think. Imagine time to collect 1 million points. Conventional surveying takes about 15.5 years. 1 million data points. Okay? Photogrammetry takes about 1.5 years. That means if you go by the traditional photogrammetry way. Okay? LiDAR, if you use the 6.7 hertz seconds at the rate of 150 kilohertz, it takes about 6.7 seconds in that frequency. So there is no game here. This is single winner, isn't it? So obviously, therefore, these traditional based surveyings are slowly getting obsolete. Now the point is, in our civil engineering courses, whether we would still like to teach the students about this chain surveying and all these surveying stuff, but still you have to teach them, right? Because these modern equipments are already used; they are being used in every applications now. Okay, and obviously, although we believe that application of LiDAR can be very expensive, but for the right kind of projects and if you can plan nicely, it can the cost also can be very effective as well. Okay. And what are the types of LiDAR? There are two types. One is airborne. That is what I was showing you. That means it can be aircraft based. There is also space-borne LiDAR systems as well now. Okay. That means satellites are also collecting LiDAR point clouds. Okay. Then airborne. Airborne means drone based. Okay. Then helicopter and aeroplanes and satellite, obviously airborne. Terrestrial is tripod. That means there are also again two types. One is called mobile laser scanning systems. Another one is called terrestrial laser scanning system. Okay. So the terrestrial laser scanning system means it is something like this. There will be a tripod, and the system is something like this size, just mounted like your light. You just mount it on top of the tripod, then it just rotates. You just select that what is the resolution that you would like to take, then it rotates. I think it's about the whole area takes about 20 minutes, 25 minutes. That's it. You have multi-millions of data points. Okay? And then at the same time, it's taking also the photographs as well. So you can do the 3D rendering, three-dimensional mapping, and beautiful. Okay? And then you have the, these days even the new Apple phones also comes up with the LiDAR. Yes, you are using? Okay. Yeah, the new Apple phones, also obviously the resolution is not that good, but they are now started using the laser scan. So now you think of the next generation Apple phones. They're going to get better and better and better and better. Okay? Good. You know the mission that the United States use to capture, what's his name? Osama bin Laden. They use this technology. There are only 4 people there in the mission, just using the right technology. And it was a night mission. Precise. Okay? How LiDAR works, I've already mentioned to you. But LiDAR, that's coming back to his question. So LiDAR has got multi-returns. That means because it's a continuous sending, blasting the signals, right? So let's say 0.0 or 0.1, the first batch of signals actually goes out, right? And then it hits the target. But again, depending on the what kind of target it is. If it is a solid target, It doesn't pass it through. But it is, let's say, forest. If it is a forest, that means obviously it can penetrate through the forest. So therefore, LiDAR are very useful for forest mapping as well, especially to calculate the forest density, crown mapping, tree crown mapping, as much as it could go actually and hits the ground. Therefore, it is very useful for detecting the landslide scar area in the deep forest, where it is impossible to collect the data from the bare earth. Okay, so the first batch of signal goes, hits actually the canopy, then it bounces back. So that is what we call the first return. In the meantime, the second batch would have gone, it goes and hits actually the trunks and the branches of the tree. Again it bounces back. So it's called second return. Then you have third return, then it goes and then hits the ground, the soil, bare soil, comes back. So therefore you have 4 return actually when you collect the data. So very, very useful. Okay, so this is what I have mentioned. I'll show you some example. So it goes first return, second return, third return, and fourth return. Okay, so if you are collecting actually the LiDAR data of a terrain, obviously you can be able to remove the forest from your data and you can create actually a digital surface model. You know what's the difference between digital surface model and digital terrain model, right? No? No? These are smart, you can write? No? But I have to learn how to? Who has used it? Pen. Okay, it's okay, I can write. So, what I was talking about.
Digital surface model and digital terrain model.
So, let's look like this. Okay, let's say this is the terrain. You have different features that exist. Okay, so the bare earth, this, that means removing all the artificial features, right? That is what you call DSM, digital surface model. Okay, whereas you go like this, this is what you call digital terrain model, right? Okay? Surface is everything. Yes, surface, sorry, yeah. It's always confusing, yeah. So, you reverse. So that means this is TM, this is DSM. It's always like the confusion between stalactite and stalagmite. Okay, so that means, obviously, so when you collect the DSM, remove the individual features, then you get the, okay? And it is very, very useful for various applications. Alright? Now, can you erase it?
Yes. Third.
Right now? Okay. Okay, so the next one, it shows that. Like you have the first return, the second return, then you have the third return, and then you have the fourth, the last return, or what you call the fourth return. Okay? So imagine now, if you are interested actually to calculate the density of the forest, this is very good. Okay? If you have those kind of data. Like you see, there's some examples of the digital terrain model as well. Some examples, some application of TLS data in archaeological site investigation. Okay, that means reconstruction of the old buildings, you know, like to know the facade and all those things also, they can be very, very useful. Alright, but it needs actually a lot of, the processing is very cumbersome because too much of data to be processed. But with, you know, day by day we are having most very powerful machines which will process the data, so that's not an issue. Alright, so this I have already spoken about it, but I think we are going to have another extra lecture, separate lecture on GNSS. I saw someone is going to give a lecture on global navigation system, so I can skip that. This I can skip. Yeah. This is, you know, GPS, why it is useful. I can skip this. Total station also you might be knowing. Then, yeah, theodolites and all that you know. Okay. So now let's go to the next one, that is GIS. Introduction to GIS. That is as per schedule, right? Okay. I think I have already spoken a lot of information about GIS, right? Geographic Information Systems. What is GIS? So if you decon the word, it becomes Geographic Information and Systems. So geographic means pretty much everything that you see outside in the real world. Okay? That means it can be any surveying data that you are capturing. It all can be geographic, starting from, let's say, electric poles to the railway lines, to the highways, to land use, land cover maps. Everything can be actually geographic information. Geographic information is that. What is that? The information about this. That is what you call the information, and it can be in terms of the database. It is being managed, right? Whether it's a relational database, whether it is a spreadsheet, or whether it is a scan image, and so on. Okay? And then you have the system. That means you have a computer, hardware. Okay? And they are all being developed actually for various applications. You can see watershed modeling, then you have for customer building, valve maintenance, forest fire modeling, oil spill trajectory modeling. Then you have, nowadays we use it for what? Insurance cases as well, drought monitoring, drought early warning systems. Then you have forest fire early warning systems, and goes on and goes on. Okay? So ultimately, the information that we derive using the GIS, it is to improve the decision-making process. That means it is a very good I mean, when you use these systems, it can be used as a decision support system. Okay, DSS. All right. So GIS is something that now you can find it in mostly civil engineering department, but also you can find in the science faculty as well. Right? In forestry department, sometimes in ecology you can find, and then you can find also in archaeology, right? Then that, what do you call that? The guys who do the architect. Okay? So the applications are many. Okay? Then it's like salt. You know, wherever you can mix it, actually it can be easily mixed. Now, what is GIS? If you want to define the GIS, so in classic way, this is a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying the data. Again, coming back to this, partially reference to the Earth. That means it has a coordinate system. It's not just actually any kind of data that we are talking about. Okay? Then, obviously, it has got a hardware, software, and the procedures. Procedures means the protocols. Right? That means the guidelines. Otherwise, it's just a garbage in and garbage out. It's just a system. Whatever you give the system, input to the system, obviously you can get the result. But the logically getting the result and the right outcome, that is what actually is supposed to be. Okay? Then, if you look at the component of the GIS, so as I was mentioning, you have software, you have the data, so that is a database management system. Then you have the procedures, that means the guidelines, okay? Then there are hardware, there's the computer hardware, then it's the people like us. Okay? The data scientist or spatial scientist. Okay? And this I have already spoken about yesterday. I can skip this. And GIS only handles the spatial data. Okay? Now, this technology, if you look back to the history, this technology has developed from the CAT. That means, okay? And slowly it has taken the shape of the modern GIS tools and the software that we are seeing today. Okay? And it follows the similar kind of DBS, the database management system, that but the computer scientists also use it as well. So that means it's one-to-one relationship, one-to-many relationship, many-to-many relationship exist in the data. And that relationship what makes actually the data enriching. Okay? So how you collect the data and the spatial relationship between the data is also very important. We'll learn about it. I have put it in a very, very simple way. So those who have never been introduced to GIS also can be able to understand. Okay. So ultimately it has to be X and Y. That means the coordinates. And if you have the G, obviously that is the vertical information or the height information. So if you look at the old and new GIS, the traditional GIS pretty much whatever is in the form of maps, typewriter, manual drafting tools, all of them can be called as actually the forefather of GIS. Okay? But the new generation GIS was all about computer based, right? Computer, plotter, then obviously CD-ROM no more. Right? CD-ROM, PDs, so many things were there, but right now they all have become obsolete. Okay? Why the need of GIS? We have understood. Obviously, when you want to manage natural resources, you have to manage so much of data, whereby the human being not being able to actually crunch the data, understand the data, that is why actually you need a system, and that is why the GIS becomes very useful. Okay, so it becomes for manipulation and analysis and modeling and forecasting of different scenarios for a given application. Okay, so some examples I have given, like the neighborhood or the intended purchase of the house. Let's say if you are moving now to Sydney, let's say someone is moving to Sydney, okay, and it's a big city. Now you would like to, you are married and you have a kid. Now you are looking at where is the good place that I can live or rent a place. Now there are so many things that has to go into your decision making process. That means the proximity to your working place, how long it is going to take, the proximity to the public transport services, because you wouldn't have a car at the beginning, okay, the cost, okay, cost of the rent, okay, so these are actually variables, okay, cost of the rent, proximity to the school, and this quality of the school, rank of the school, okay, in the state, so many, and the list goes on. And if your husband is fussy, he would have his own, okay, husband or wife, whoever. So when you have so many variables actually to take into consideration, that is, I'm just giving a very simple example. That is where actually when when it becomes actually complex, that's why we need this kind of systems. Okay. The route for firefighting vehicles to the fire area. That means if there is a fire is happening, what would be the best way actually to get into the area to put out the fire, for example. Location of the historical sites to visit, and these things are already being, people are using. A lot of agencies also have been using the GIS. Okay. Similarly, the Earth's surface also has a very limited resource. So to efficiently manage our resources, obviously we need the GIS. Okay. So you know now why some of the precious minerals are very expensive. Why? So demand and supply. When the supply is less and the demand is high, obviously the price goes up. Isn't it? Gold is expensive. Now, why? So why 85,000 1 gram? Right? Why? Because we don't have much gold left. But let's say imagine there are 5 or 6 countries now, they would find huge reserve of gold. You see the return. Similarly goes also for oil, because India doesn't have much oil, right? Oil reserve. Now if you find actually a lot of reserve, let's say in Lakshadweep or somewhere, or the off coast, see oil price will go up. And these are the non-renewable natural resources, right? So once finished, this is gone. Now they say, NASA is saying, there is a huge reserve of gold probably is in Mars. But then the cost of going down, digging down, actually doing the mining, then processing that. Because to get a bit of gold, it needs a lot of processing. It doesn't come like what you see that 24 karat gold. Right? They have to dig a lot of dirt and soil. You know the deepest gold mine is in South Africa. Okay? So, and if you see, like, it's such a dangerous place to work in. It's about 3-4 kilometers down the earth, just to get some ounce of gold. And that is why it's expensive. The same also goes for diamond, right? Even more rare. Okay, platinum, more rare, right? So that is why because of the limited resource, so we can probably use, and they are using GIS actually for managing the shaft and the different ways that how they can planning of the digging down the dirt and all that thing. Also they use 3D GIS. Okay, and also this helps for fast and quick information for decision making, because ultimately you have to make the decision quick. Okay, good. This I can skip now. There is a old saying, it goes, a map or a figure speaks thousands of words. Okay? Our mind actually captures very quickly when you see some graphical representation, rather than actually having presenting thousands of words. Right? It gets bored. Mind gets confused. But if it is an image, if it is a map, if it is a graph, immediately we can be able to understand, and we can infer information from it. I have given a simple example here. The example is from the Peninsular Malaysia. So now you see, if I give, and they have only about 7 states are here. But now in India, let's see if I give you, but how many states now? 20. So sorry, because it's keep on increasing, so it's very hard to follow. All right. So 28 states, let's say. Now, this is just one information that is given here, population. Now think about complex of the information that if we keep on putting GDP, literacy rate, blah, 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 just keep on adding, right? Then whether the information that you would like to visualize and can be able to, derive the information easily from here or here. So the graphical representation becomes much more easier, and that's what makes actually the GIS very powerful. But it's not being limited there. Many people, they think that GIS means it's all about map. No, not at all. It's beyond map. Map is just one of the output just to present it. But you can do reporting as well. You can use GIS actually for creating a report. With GIS you can do report, then visualization, then simulations, then predictions, everything can be done there as well. Then location. So now I'm just going into a little bit of technicality of the GIS. Okay. Now imagine you have 3 different types of features here, and we have given some local coordinates here, because at the end of the day it's all about coordinates, right? So here I have given here east and this is the south. Now if I would like to say where is the X located, how do you define it? It is 3 of
3 of south, 3 of south.
3 of south and 12 of east, right? So another question I put, what can be found at a certain location? For example, what can be found at 5B south, 5 of south, 5 of south, and 11 of east. Okay? So this is just a simple example for you so that you can understand. But now, when you store the data, so obviously this is just a map representation, but the data has to be captured in a database, right? So that means each feature should have a unique feature ID, and then it should have its X and Y. unique feature ID I mentioned. Okay. Yesterday I mentioned you all data should be captured in points because the line also represents connecting between 2 points. The polygon represents actually connecting multi points and closing it, right? So ultimately, this is all about the point, right? And each point should have a unique feature, okay? And then you have its x and y values. Now, let's look at the other part of the GIS data. One is the spatial, another part is called attributes. Attribute means what? The information that actually that particular point contains. Okay. For example, here I have given a very simple example here. See, there are about 5 data points I have, or 5 locations you can say, or 5 feature points you can have, and then each of them, let's say, it provides the area. What is the area of these points? Who the owners are? What is the tax code they have? And what is the mineral quality they have? This is just an arbitrary example that I have given. Okay. Now, if I ask a question, what is the attribute for item 2? Item 2, the owner is Braudo, and he has an area of about 50,100 hectare. Tax code is falling within the bracket A, and mineral quality is blah, 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 medium. And let's say there is another question I ask where a certain scenario might happen. See, these are the questions that you can ask when you have the data. First question, what is the attribute? Where? What? Okay. Second is what scenario? Example, who has the highest quality of mineral? Ultimately, it's all being managed by Excel, right? Because Excel data also can be, as long as you have the XY. They all GIS allows you actually to convert the data from one format to another. It's database format, obviously. Okay. Then now let's look at the relational database. Okay. So same example, the owners are there, and then tax code, mineral quality. Now the question I ask, selection of an area, okay, according to the rules that we have set here. For example, which item has area greater than 40,000 hectares? That means all of them? All of them has 40,000. Owner is not Silima, that means you exclude this. Okay. Tax code is paying B, that means only 2. Okay. What is the mineral quality? Tell me. Yeah. So what is the mineral quality? High? Why? Area is greater than 40,000, all. Owner not Silima, excluded. Tax code is B, so that means 1 and 3. So the mineral quality can be high or low. Why are you expecting only one answer? Yeah? I mean, this is just an example, simple example that I have given. That means just to understand that a lot of queries can be done when you have the database. Right? I mentioned, right? GIS allows you to query. Okay?